Hello everyone. In this video, I'll teach you about Bit and Byte, which is the building blocks of computer memory. So, to begin, I want to say that computers use only 0 and 1. For example, let's say you are watching a movie, or let's say you are doing some calculation, but our computer doesn't know anything about it. Only knows 0 and 1, and 0 means there is no voltage and 1 means there is voltage. Okay, the 0 means absence of voltage and 1 means presence of voltage. So this 0 and 1 are called binary digits. Okay, let me take the pointer. These are binary digits because there are only two digits, either 0 or 1. That's why they are called binary digits. And binary system forms the foundation of computer memory and processing. So let's go to the next slide. So to store these 0 and 1, computer needs memory, right? In a place, the computer need to store this 0, 1, or the sequence of 0011, 0001, like that. And memory stores binary data, whether it's text, image, or programs. I already mentioned you that suppose you are watching a video. You are watching video, but computer doesn't know that it is a video. It only knows only 0 and 1. Okay, only 0 and 1. And each storage location holds a bit. It means uh, it can be either 0 or 1. Okay, so everything is 0 and 1, right? It is so easy, right? Of course it is easy because you are so intelligent. Okay, so bit is the smallest unit of data in a computer, and it can have only two values, 0 or 1. I already mentioned that, 0 or 1. The whole lecture will be on 0 and 1. And after that, we will go further like character, integer. Until then, stay with just this mini concept. Now let's jump more forward. For example, with just one bit, we can represent two values. It can be either 0 or 1. But with 2 bit, look at here. These numbers are with two digits, right? So this is first bit, this is second bit. This is first bit and this is second bit. This is first bit, this is second bit, and this is first bit, this is second bit. So with 2 bits, we can represent total 4 numbers, right? 0, 0, 0, 1, 1, 0, 1, 1. Okay, but what will happen if we take 4 bits? How many values it can hold? Let's check. With 4 bits, we can hold only 16 values. How is that possible? What are these 16 values? Let's see with an example. Okay, let me take a text box. Okay, I will write 16 values here. The first one should be 0000. We are talking about 4 bits. Okay, so there are only four places, and we have used all 0. Then we will take 0001, 0. Let me do something. 0010, then 0011, then 0100, then 0101, then 0110, then 0111. How many numbers are here? 1, 2, 3, 4, 5, 6, 7, 8, right? Only 8 numbers. And I will just copy paste this, and oh my god. And I will making all 0 as 1. So these are 16 unique numbers that we can represent with 4 bits. This is so simple, right? There are, please count, there are only 16 numbers. If you don't believe, you count. And if you are intelligent, you don't need to count, okay? So Do you know can you understand the pattern that with 1 bit we can get two values, with 2 bit we can get four values, with 4 bits we can get 16 values. What will happen if we take 8 bits? What will take if we take 32 bits or n bits? There's a question, right? So the answer is, if we take 8 bits, we can represent 256 values. On the other hand, if we take n bits, we can uh, it can hold 2 to the power n values. For example, if we have only 1 bit, then it is actually 2 to the power 1. This is 2 to the power 2, this is 2 to the power 4, this is 2 raised to the power 8, and this is 2 raised to the power n. So we all have understand the formula that if we have n bits, then it can hold only 2 raised to the power n values, right? This is simple, very, very simple. Next, let's move forward. Now we are going to the journey of byte. What is a byte? Byte is actually 8 bits. Consecutive 8 bits represents a byte. And as it is 8 bit, it can store 2 raised to the power 8, that means 256 different values. It is a common unit to store characters or small numbers. So now in C or C++, we can represent character with just 1 byte. 1 byte means what? 1 byte means 8 bit, right? Of course, 8 bit. Each character is mapped to a number. For example, if we see the small a character, then its corresponding number is 97. If we print a with integer value, it will print 97. If we print b, it will print 98. If you print capital A, it will print 65. If you print zero character, then it will print actually 48. This mapping is called ASCII. The full form of ASCII is American Standard Code for Information Interchange. But there are there here we can only represent 256 different values, and which are from English, right? So what about other languages? Actually, ASCII covers only English letters and symbols, but Unicode supports characters from all languages. Unicode uses actually more than 1 byte per character. So now we will look a program so that we can get a better understanding. Let me open my VS Code, program1.c. Okay, okay. Then let's start. We are including the header file, and then it main. Actually, I am going to print the ASCII values with their corresponding letter. So for I is equal to 33, I is less than O. And it is showing some good suggestions. And I'm going to print ASCII code for percentage %C is percentage %D. I'm going to write this. And percentage %C means I, and percentage %D means also I. Okay, I think I'm all right. Then lastly, return 0. Writing return 0 is just a good practice. Okay, now let's run this code. So what are we doing in this code? We are just going through 33 to 126 and printing there that character with the corresponding ASCII values. The ASCII values are from 33 to 126. Okay, so run this code. Let's see what happens. Okay, so you can see the output here. Uh, Okay. So look at this. The explanation sign ASCII value is this. Okay. Then ASCII value of quotation is 34. What is the ASCII value of 0? This is 48. I already told you. ASCII value of 0 is 48. Then ASCII value of character 1 is 49. ASCII value of character 2 is 50. Then where is capital A or small a? Here, capital A. The ASCII value of capital A is 65. ASCII value of capital B is 66. Okay. And what about small a, small b? Where is it? Here is it. Here it is. The ASCII code for A is 97, small b is 98, small c is 99. So why now, right now you have a question, right? That why are we doing this loop from 33 to 126? Why not 0 to 255? Okay, because we can print the values above 127 because they are not printable. That means it cannot be shown in the screen, or if it can be shown in a screen, it will be some clumsy letters and we cannot recognize it. And um, that's why I have written only from 33 to 126. Let me check if the video is going. Yeah, it's going. Okay, this was my our first program. Now we will write our second program. Let's see. So you must write this program so that you can have a better understanding of what is going on. Okay, and you should just do some experiments with the code. And if you do experiment, you will learn a lot. Okay, so we will now start some small letter. We will play a game with small letter and capital letter. So I am including the header file stdio.h, then int main, okay, then character. We will the user will give a small letter character and we will print the capital letter character. Okay, so character is small letter and another will be capital letter. Okay, so user will give a small letter. Okay, and we will print the capital letter. Okay, this is so super easy. But you may have a question that why capital letter is equal to small letter minus 32, right? Of course, you have the question. Uh, if you don't have this question, then you are very intelligent. Okay, so look at here. ASCII code for small a is 97, right? Okay. And ASCII code for capital A is 65. Then what is the difference between small a and capital A? It is 32. That's why capital letter, the ASCII value of capital letter is smaller. The ASCII value of capital letter is smaller. That's why I am subtracting 32 from the small letter ASCII value. And let's see what happens if we run this program. Let me check what happens. Okay, so here it is. So the prompt is telling me to enter a small letter for this printf, and I am writing, for example, D, small d. And if I press enter, and the magic, the capital letter is the capital D is printed, right? Because of this formula. And the relation between capital letter and small letter is capital letter is 32 value smaller than small letter. The value of small letter is bigger than the value of capital letter. This is something contradictory, right? Haha, it was a nice joke. Okay, so we have already seen two programs. Okay, now I am going to give you a task. So this is the question. You in this task you will write a function that takes a character as input. Then if the character is a digit, then it will return 1. Otherwise, it will return 0. So now pause this video and please write in the comment section with the answer in the right answer in the comment section. And after that, just resume the video. Okay. So here it is. This is the name of the function is digit. It is taking a character. If the character is from 0, character 0, and uh, is less than or equal to character 9, then it is returning 1, otherwise it is returning 0. Super easy, right? Of course it is easy. Haha. Okay, so now we will move further. We will now introduce integer type and bit size. So in C and C++, integer usually takes 4 bytes, which means 32 bits. So using 32 bits, we can represent 2 raised to the power 32, which is approximately 4.29 billion numbers, which is huge. If we take only positive numbers, that means unsigned integer, it can hold 0 to this value. It is 4.29 billion. And if we want to store both positive and negative values, then the range is from minus 2.14 billion to plus 2.14 billion, minus this number to plus this number. And why minus is greater than plus? Because there is also 0. 0 is also a number, right? So that's why we need to give a small space, place from either from negative side or either from positive side, and by convention it is given from the positive side, nothing else. So to summary, we can tell that computers understand only 0 and 1s. Data is stored in bits and bytes, and 1 bit means 2 values, 8 bits means 1 byte, which can hold 256 values. Then we have introduced that characters are stored using ASCII or Unicode. Numbers are multiple bytes. For example, integers, we have already seen that integers are 4 bytes. Then bits and bytes are fundamental to everything in computing. Yeah, it is. So if you have any question, please write down in the comment section. I will try to give answer as soon as possible. So thank you very much for watching this video. Bye bye and take care.